Good morning, everyone. Welcome to today's Exploring by the Sea Urchin Hangout. My name is Joe Gorowski, and I will be your host for today. Really excited to be taking a virtual field trip today, and actually our first event of April. We are heading for another event with Ocean Wise at Vancouver Aquarium. We're really excited to be joined by Rachel Bell Irving today, and we are going to learn all about the invertebrates. And it's about time. The vertebrates get way too much publicity, way too much attention. There are so many amazing things going on in the world of no backbone, so we're really excited to learn a little bit more about the inverts and some of them that are located at the aquarium. So Rachel, it is so great to have you joining us today. Always great to steal a little bit of your time.
Thank you so much, Joe. I could not have said that better myself. Of all the animals in the world, 97 are invertebrates. They've got no bones, and because of that, they come in a magnitude of different sizes and colors and shapes, and some of the craziest things that you can imagine come from the invertebrate world. So if you're looking for inspiration to create your own monster or a superpower creature or something like that, invertebrates are amazing animals to look for inspiration. So as Joe said, my name is Rachel, and we are currently at the Vancouver Aquarium. A good little wave. Has anyone been to Vancouver before? Oh, I see one or two hands. That's exciting. Awesome. So Vancouver is located on the western side of Canada. We're actually quite close to the Washington border, and we are located in Stanley Park, which is a big city park, even bigger than Central Park in New York. And it is on the traditional territory of the Musqueam, Squamish, and Tsleil-Waututh First Nations peoples. We're right in the heart of a rainforest, which means we have some incredible invertebrates that I have brought a few with me as well to show you. The Vancouver Aquarium is a nonprofit. It's part of Ocean Wise, and so we are dedicated to trying to inspire others and pursue conservation and research around the world, and hoping that everybody recognizes that they have a part to play in keeping the oceans healthy and protecting amazing animals like this. And I did bring a few with me. We're currently in our wet lab. This is a behind-the-scenes space. So most people, when they come to the aquarium, never get to see this room. You're one of the lucky few. You might see some people walking around behind me at some time. That is our animal care staff. They're aquarists, as we call them, and they're helping to take care of the animals, which I can definitely speak to. I've done it myself. It's quite fun to look after invertebrates. So without further ado, we're going to get started. And the reason we talk about invertebrates is because they are so important. Invertebrates take up a really important part of the food chain and have really vital jobs in their ecosystems. Every animal has a job to do, and when we remove a piece of the puzzle, we can cause a lot of imbalance in the ecosystem, which eventually affects humans as well, because we rely on the ocean just as much as all the animals do. So I'd like you to take 30 seconds and talk to your neighbor and think of some of the ways that we use the ocean. Even if you're in a landlocked area, even if you've got rivers and streams that are all connected, take 30 seconds, talk to your neighbor. What do we use the ocean for? Go.
You want me to put some classrooms on the spot and see what they were thinking of?
Yeah, that'd be great.
All right. We'll give them another couple seconds. We don't have like
no pressure. No pressure.
Something going right now. All right, I see conversation. There's some conversation going on. All right, let's start picking on some classrooms. Let's go to Mrs. Russett's group. What were some things that you thought of that we use the ocean for?
I was on a big boat that took us in New Brunswick, and there was a great.
Go ahead and shout them out, Mrs. Russett's group.
Sports. Yeah.
Awesome. I'm glad that you went there first. So it's like, obviously we've got some other things, but sports are something people forget about. We can go swimming, we can go water skiing, tubing. Awesome.
All right, let's check Mrs. Wood's class, see if they have something. Maybe one at a time. What are some things we use the ocean for?
Swimming.
Awesome.
Good ones here. Fishing. Fish.
Fish, swimming, seafood. Awesome. Seaweed, if you like eating seaweed.
All right. 5. Mrs. Galato's class. Let me make sure I can get their microphone. Oops, I missed it. Right near the bottom of my page. There we go. What do you think, grade 5? What do we use our ocean for?
Someone raise your hand. Go ahead. Nice and loud.
Right near the bottom of my page. There we go. Next, what do we use our open for?
Ethan, nice and loud, please.
There we go. What do we use our open for?
Ethan, nice and loud.
Sorry, I'm getting a really weird loop of audio.
Yeah, we're gonna, for whatever reason, maybe they're watching on YouTube as well. We're getting a feedback loop, so we'll assume it was something awesome.
Yes.
Yeah.
It usually is.
Yeah.
All right, so those are some really good examples. I like it. We've got things like our food and we've got water. We get a lot of our oxygen from the ocean as well. Over 50% of the air we breathe comes from underwater plants in lakes, in oceans, in all the rivers as well. So we get a lot of resources from the ocean that we have to have simply to survive. And then we've got a lot of emotional connection to the ocean, of course, with our sports, with swimming, maybe painting or drawing or writing stories, all of those kind of wonderful things as well. If you have ever ordered something from Amazon, it's probably come over the ocean as well. So we are really closely connected to the ocean, which is why we need to do a better job of understanding it and seeing the little things that we can do every day to help protect it. So what I'm going to do is I'm going to introduce you to some of those invertebrates, because when we get an understanding of what these animals are, how they work, they can help inspire ideas for future change or even maybe some inventions or some kind of medical facilities as well, which is really exciting. So I'm going to introduce you to a group called Echinodermata. It's a big word. I've got it here to show you. Echinodermata. It's a very big word, but basically when you break it down, echino means spiny and dermata means skin. So we're looking at a group of animals that has spiny skin. And the helpful thing about invertebrates is that they're grouped into these phyla all based on sharing characteristics. So everybody a part of the Echinodermata family is going to have the same characteristics. They're going to have the same sort of features about them. And even then, they come in lots of different shapes and sizes. So the first one I'm going to show you is this awesome animal here. And I'd like you to make a few observations. Here is my first invertebrate. There we go. We've got what is called a green sea urchin. So these are local to Vancouver, but the sea urchins can be found all around the world. And you've got this very circular shape covered in what we call spines. So if you think of a pincushion, that is essentially what a sea urchin looks like. And then they also, on top of that, have these weird tentacly looking things coming out. And those are called tube feet. They're very much like your fingers. If you wiggle your fingers, very much moving the similar way, except they've got suction cups on the end of each tube feet. And there are hundreds and hundreds and hundreds of them to help the sea urchin move across a really bumpy and rocky landscape. So thanks to these suction cups, thanks to these tube feet, they can go upside down rocks, they can climb under things, they can go sideways up cliffs. They're a very cool animal. And so that's one of the key features that makes them an Echinodermata is the tube feet. Everybody a part of this family has to have tube feet. So if you're looking at even something like a sea star, for example, they were going to have hundreds and hundreds and hundreds of tube feet all underneath each of those arms. So imagine if you were trying to live with thousands of tentacles sticking out all over your body. That is how they live. That is how they do. It is a pretty cool animal, and it's a great adaptation, but with all adaptations, it comes with a trade-off. And you can do these observations with any animal. If you look at a feature it has, for example, tube feet, it comes with a trade-off. And I'd like to pick on classes again. Hundreds and hundreds of feet. What do you think is the downside to having hundreds and hundreds of feet?
All right, the downside to hundreds and hundreds of feet. Let's pick a group. Let's go to Mrs. Gouzet's class this time and see what they think. What do you think the downside is to having hundreds and hundreds of feet?
She said if they're trying to do something, their suction cups get in the way.
Suction cups get in the way. Yeah, I could say that's a really good way to describe it, because when you have hundreds and hundreds of feet, that's hundreds of feet you have to coordinate, and they get in the way. It makes them quite slow. So it's a really great adaptation for something living at the bottom of the ocean, for a benthic organism, something at the bottom of the ocean, because it allows them to climb under and over rocks. But at the same time, they're going to be moving very, very slowly. And so they need another adaptation to help protect themselves. Awesome job. And that's where that spiny skin comes into play. So we've got tube feet as part of Echinodermata, And then we have to have spiny skin. Sea urchins are pretty obvious. They've literally covered in spines. They're covered in all these crazy spikes. I was trying to pick it up, but it is also a very strong creature because of all those 2 feet. And this one does not currently want to move. So we're not going to pick them out of the water yet. But again, spiny skin, and they have to have 2 feet. So here is another echinoderm that we're going to pick up. Has anybody seen this creature before? It's a bit of a strange one. It looks very much like a log, covered in spikes. And of course, we've got those 2 feet underneath as well. This is called a sea cucumber. This specific one is a California sea cucumber. Now, I'd like a guess from another classroom. What do you imagine it would feel like if you were to touch the sea cucumber?
All right, let's go to Mrs. Rodriguez's class. Let's see if they have a guess. What do you think that cucumber feels like?
What do y'all think?
Slimy. I love the word slimy. Slimy is a great descriptive word. And you are correct. It has spikes. It's got these kind of, actually what we call fake spikes. So that is still spiny skin, but with this cucumber in particular, those spines are all fake. They're just filled with water. And so if you were to touch it, it actually feels a lot like velvet. If you're touching velvet. When the sea urchin, on the other hand, it feels really much like you're trying to poke a pincushion. So if you are walking on a beach that has sea urchins, I definitely recommend you be careful because speaking from experience, it does hurt when you step on one. They're quite dangerous in that way. So nicely done. Even though we've got 2 animals a part of the exact same phyla, they look incredibly different. And they still have to follow the same characteristics. We've got 2 feet. We've got spiny skin, and the last one is what we call Penta radial symmetry. Penta means 5, radial means around, symmetry means the same. So we need basically a rule of 5. And I'd like everybody to hold up your hand like a sea star. Excellent. How many fingers do you have? 5. So this is the first way to look at it. Sea stars are one of the easiest. They've got 5 arms. They've got 5 rows of 2 feet. Nicely done. Now, if you take your 5 fingers and you curl them into a ball, it starts to look a lot like a sea urchin. And that's the same thing. Our sea urchins have 5 rows of 2 feet, just like where your knuckles are, all the way around their body. Now, if you take your 5 fingers and you curl them into a tube, again, you start to look a lot like a sea cucumber. And you've got 5 rows of 2 feet all the way around. So echinoderms have those same characteristics: 2 feet, the spiny skin, and pentaradial symmetry. Thanks to these characteristics, we're able to not only identify what the animals are, but we start to identify the amazing adaptations they have and their roles in the environment. For example, sea urchins, I like to call them the garbage disposals of the ocean because they will pretty much eat anything that gets in their way. And they've got a really cool mouthpiece that we call Aristotle's lantern. It's basically 5 individual teeth that are curved into a point at the end. So again, if you take your fingers and you make sort of like a claw, that is what the sea urchin's mouth looks like. And when you get them up nice and close, you actually get to see those individual teeth moving, very much like an alien that you might see in a horror movie, with those kind of like type of teeth. And it's thanks to these really powerful teeth that they're able to gnaw through either usually dead carcasses are a big one, and they also love to eat kelp as well. So of course, sea urchins, if they're left unattended, if there's not a predator to control their population, they could eat through an entire kelp forest. And that is why that balance is so important, because a little thing out of whack can mess up the entire ecosystem. Every invertebrate has an important job to do. They come in tons of different shapes and sizes. And it is about time that we give them some attention because, like I said, 97% of all animals are invertebrates. They fill some of the most important jobs at the bottom of the food chain, supporting all of the really cute and cuddly and dynamic animals that we love so much. And if our invertebrates are going to be damaged by the environment, then everything else is going to be infected, including humans as well. So imagine if sea urchins disappeared, if our kelp forest disappeared, all of a sudden that entire ecosystem that gives us oxygen, that gives us food, that gives us fish is gone. And humans are just as much affected by that. Does anyone here just by a wave like to eat crab or shrimp or clams or mussels? I do as well. It's delicious. Those are invertebrates. Those are another type of animal that we love. And even more so, it's an important food source for us, for a lot of coastal communities and around the world. So the more that we pay attention to these animals, we can hopefully learn something incredible. The other really neat thing about sea stars specifically is they've got this ability to regenerate. So imagine you lost your arm in an accident and you could just regrow it over the course of a year or two. Yeah, wow. So that's what sea stars can do. If they lose an arm, they can actually regrow it back to a certain degree. And scientists have looked at that and said, well, wouldn't that be amazing if humans could do something like that? So these animals have also inspired a lot of research and a lot of creative ideas for people to try to overcome our own problems, whether that's anti-aging or that's regeneration or biotronics or bridges and buildings and camouflage and all these amazing things that we can invent by taking inspiration from the ocean. So I encourage you to try and find an invertebrate where you live. That might be the ocean, that might be a lake, a river, maybe even some bugs in your backyard. And just take a moment to look and listen and watch and see what you can discover about your own animals just by giving a couple seconds to these amazing, amazing animals. And with that being said, I'd like to know if you have any wonders or curiosities about these animals and anything behind me.
All right, Rachel, thanks so much for sharing that with us. It's, yeah, like you said, 97% of the animals on our planet and all kinds of amazing things. Important part of the food chain. Some of them can regenerate limbs. Invertebrates are pretty awesome.
Yeah, they've got so many superpowers, I like to call them. It's quite fun.
All right, we've got a bunch of classes who are watching along on YouTube today. Remember, on the right, you can get in on the action, use the chat sidebar and send us in a question or two. Of course, let us know who's watching. And I want to give a quick shout out to Mrs. Lee's class. They're grade 6s in Ottawa, Ontario. They're watching along on YouTube. And in fact, they've already fired away a question. And they're wondering, how many species of invertebrates do you have at the aquarium?
Oh, that is a very good question. I don't know the specific number off the top of my head. We are actually currently going through our census, which we do every year, which actually means basically counting every single species that we have. In here specifically, we've got mostly 4 different phyla. So we've got Echinoderms, which are the spiny skins. We've got mollusks, which are shelled animals. So that's like mussels, clams, as well as sea slugs. That's a really cool one, nudibranchs. We've also got cnidarians, which are stinging animals, so sea anemones and jellies. And then we've got arthropods, which are jointed animals. And we've got a couple different crab species. So in this room alone, there's quite a bit of diversity. And that doesn't include all the other animals that we have in the other habitats as well.
All right, good question to get us started. Any classrooms online, keep those questions coming. Let's go to one of our live classrooms. Let's go now. Let's start off with some grade 5s hanging out with us in Lufkin in the United States. Mrs. Gouzet's group, let me get your microphone turned on. Let's see how you guys are doing. How are we doing, grade 5s?
Good. You have questions? What was your question, Daniel? Diego? Questions? You have questions, Darius?
What's the population of starfish?
She wants to know how many starfish y'all have.
That's a really good question, actually, because back in 2013, we nearly lost all of our sea stars. There was a big disease that happened called the sea star wasting syndrome, and it was quite a massive epidemic where sea stars from Alaska down to Mexico basically were nearly wiped out. Our sunflower sea stars dropped around 80% of their population. So during that time, we actually lost a number of sea stars. They seem to be getting better now, which is great. The bulk of the disease seems to have passed, but we still really don't know a lot about this disease or why it happened or what caused it. So that is a future area of research if anyone's really interested in sea stars. Here in this room, we have a lot of what we call bat stars, as well as leather stars. And then in our other wet lab, we have ochre sea stars, which are the really strong, bright purple ones.
All right, let's jump to another classroom. Let's go to, let's see, let's go to Toronto this time. Toronto, Ontario, some grade 5, 6s with Mrs. Woods. Let me get their microphone turned on. How are we doing, grade 5s?
Hi, good. So we wanted to know what the scientific name for the sea cucumber is, and we were wondering if you were going to hold the sea cucumber.
Scientific name for the California sea cucumber is, I'm going to actually look it up because I don't want to get it wrong and I'll pronounce it wrong. So it's, oh my gosh, Octopus californicus. And I've taken Latin in university and I still probably said that wrong. To be honest, Latin names are really helpful. Thank you, I appreciate the applause. Latin names are very helpful because again, those words can tell us a bit, but I don't personally memorize most of them because they can be very challenging for me. But that being said, I actually, I can try and pick up our cucumber. I'm gonna see if it looks like it's feeding right now. So let's see. You can actually see that little flowery bit is its feeding tube, or feeding tree, sorry. So it's coming out and it's tasting the bowl. The challenge with sea cucumbers is unlike the sea urchins, they don't have that, what we call an exoskeleton. They don't have that protective shell. And so picking it up out of the water actually can be damaging if I take it out for too long because that needs its water to hold its shape and to survive. So I can pick it up for a moment if it'll let me, but it seems to be, it's stuck pretty hard and I don't want to bug him too much. Remember, they are animals. I'm going to try and be respectful. So I'm sorry I can't pick this one up, but you can imagine if you've ever played with goo, that's pretty much what the sea urchin will happen to the sea urchin if we bring it out of water for too long. It goes, bleh. It's quite fun, but we got to be careful with them as well.
All right, well, I'm going to jump back to the online community because there's a couple classrooms who have sent in some questions. And in fact, 2 of the classrooms are on the same page and they're thinking right now. We've got grade 5, 6s with Mr. Richards in Amherst View, Ontario. And then we have grade 4s with Mrs. Fusco in Algonquin, Illinois. And they're both wondering about poisonous invertebrates. Are some of them poisonous, and is there one that stands out as being dangerous to humans?
That's a very good question. The one thing I want to specify first is that there is a difference between poisonous and venomous. And you can help show all your friends this little trick as well. Poisonous means you have to ingest it or eat it. So for example, if you were to lick a poisonous frog, that would make you sick. Or if you eat a toxin, you've been poisoned. Venomous refers to injecting or stinging. So if it actually like stings you, like a bee sting, for example, that's venomous. So I'm not familiar with poisonous ones specifically, but venomous ones, absolutely. Our entire phyla of cnidarians in the back there are all characterized because of their ability to sting people. So we've got sea anemones, which stick to the bottom and they've got their tentacles sticking up. And we've got jellies, which are the bell shape that kind of floats like this. You can do a jelly fist pump with your friends if you want to give that a try. So yes, those can be very dangerous to people if we were to touch them. More so in tropical waters, you see a higher number of venomous species. In British Columbia, particularly in North America, we're quite lucky. They definitely can hurt. All jellyfish sting, but they don't necessarily hurt as much as some of the more tropical species.
All right, keep those online questions coming. Let's jump to another classroom. Let's go to Odessa this time. We have a group of 5th graders hanging out with Mrs. Rodriguez. Let me turn on their microphone. There it is. How are we doing, 5th graders? Good. Who's got a question? I see someone.
If a starfish could regenerate, then how would it die?
Yeah, it's a great question. There are lots of threats in the ocean. So the trick about regeneration is you've got to have time and you have to be really healthy to begin with. If you're already sick, like with the sea star wasting syndrome or disease, then unfortunately you don't have the strength to regenerate as well. So that's the big challenge for a lot of invertebrates is they could potentially live to be very, very old. The oldest living invertebrate that I've heard of is a sea anemone in an aquarium in the UK that was over 150 years old. So they can get to be very, very old if you give them the time and the healthy environment to survive. But you've got predators, you've got now a lot of pollution and human destruction. You've got each other to worry about, competition from other members of your species. So there's a lot of reasons why they might not have the time or the strength to regenerate.
All right, great question. Let's see. Let us go to Mrs. Russett's group. They're in Arnprior, Ontario.
Nope. Okay, go ahead, Rachel.
All right, we're ready.
If they have no spine, then where do their limbs connect?
That is a great, very thoughtful question. And that also depends if they've got limbs at all. So some of them don't have limbs like we do. Like we've got the joints and things like that. So we're actually quite closely related to, I would say, visually, we look a lot like crabs because we've got their joints. But that is what I think is the most amazing thing about invertebrates, is they really change the way we think. They don't have limbs, so they don't have anywhere for them to connect. For the sea urchin, as an example, come on. Oh, there we go. Thanks, buddy. The sea urchin, for example, it has an exoskeleton. It's got a round sort of shell, essentially, just underneath those spikes. And that's what all the spikes are able to connect to. And then they've got muscle on the inside of it. So that is where their spines connect. That's where their tube feet connect. But it really does depend on the type of animal. And they defy our imagination. If you can think of it, it probably exists somewhere in the world, which is really cool.
All right, very good question. Let's see. Let us go now. So Mrs. Hood's got a group joining us, and they're in Connecticut. There's some students hanging out in the library, and they have a really good question they just sent me, but let's see if somebody wants to ask it. So let me get your microphone turned on. How we doing, Connecticut?
Hey there. Good, right? Great.
All right, who wants to ask that question? That was a good one.
So because we live in Connecticut, how do the invertebrates from the East Coast differ from the West Coast?
Yeah, that's a very great question. I like that you're thinking about your place as well. The species are different depending on the type of animal you look at. So you likely have, in the ocean particularly, you're going to have invertebrates as well, but they're going to be different species. So some of them span the entire globe. Others are region specific. And that can depend on the conditions of the ocean. So whether it's a mild ocean, whether it gets really, really cold or really, really warm, those are all factors that go into it. So I really encourage you to do some research and find out what invertebrate species you have on the Atlantic coast. And then you can kind of cross compare to see what they look like.
All right. We've got Mrs. Galato's group. They're hanging out with us, some fifth graders. How we doing, fifth graders?
Good. What would happen if we didn't have sea life at all? How would that affect us?
If there was no sea life at all, these are the good scientific questions that we want to ask to be curious and do some more research. Short answer is, if we don't have the ocean, the planet does not survive. So the ocean, we have to have it in order to live, because if you think about a giant pie, if that was our planet, the ocean covers 3/4 of the pie. We know more about space than we currently know about our own planet, because of that, it covers 71%. We've only explored 5% of it. So that's tiny. We don't really know much at all. What we have learned since doing that research is that we get the ocean for our oxygen, for our food, for water, minerals, medicine, transportation, climate. So that's a big part of it. The ocean actually helps regulate the climate. It helps protect us from storms, or it causes storms. And all of that keeps our planet healthy. If we don't have a healthy ocean, the planet as a whole is going to suffer. And sea life, like these living animals, are a big part of that as well, because they're all working together to maintain that balance.
All right. Rachel, I'm going to throw a couple more questions from our YouTube community at you.
Cool.
Let's see. We've got some second graders who look like with Mrs. Pavdebo, and they're wondering, how big can sea stars grow?
That's a great question. Sea stars, the biggest type of sea stars are the sunflower sea stars, which they actually have 20+ arms. So it's a big, massive sea star. I don't know if we have any at the moment, but they can be about the size of a dinner plate. So if you're a second grader and you make this with your arms, that's about, actually, you know what? They could probably be about this big as well. I have seen one about that big. So they can grow to be about the size of a dinner plate, or if you make a circle with your arms, about that big.
All right, and one more from the online community. Let's see. This is an interesting one. This is from Mrs. Lee's class in Ottawa. Tropical region are more poisonous or venomous than maybe North American one.
Sorry.
Is there any reason?
The first half of that cut out. What was the question?
Oh, sorry. They're wondering, they're observing that are more venomous or poisonous than species further north. Is that something you've noticed?
Which animal? Or just all invertebrates?
I think just in general. It seems like most invertebrates seem to be, most species you hear about are from the tropics. So they're wondering, are there northern species that are venomous as well, or is it more to the tropics that it's confined to?
The only ones that I personally have experience with or knowledge about that are venomous and poisonous are the ones in the tropics. There are a ton of invertebrates actually in the Arctic. So up in the frigid cold waters. Ocean Wise does diving up there every year, and we take surveys of the area to count and see tend to be larger. So it's called gigantism. So they actually grow larger than more southern species. Not entirely sure why. There's a couple different going theories for that one. But yeah, that's a really common observation. More tropical species tend to be venomous. Haven't seen that very much myself with other than northern species.
All right. Well, we have a few more minutes, so I'm going to try and do a swing through some of our camera classrooms. Mrs. Guzet, do you guys have a follow-up question?
Morning. Microphone's up there. Okay. Right here on my computer.
How many?
He wants to know about octopus.
Sorry, something about the octopus?
Yes, he wants to know if y'all have any.
Oh, yes, we do have an octopus. We do have a giant Pacific octopus whose name is currently Seth Rogen. You've heard of the actor Seth Rogen? Yeah, Seth Rogen. So that octopus is in one of our gallery habitats, and the giant Pacific octopus is very cool. If it's at a full-grown capacity, it can reach 20 feet. So if you look at one end of your classroom to the other, it could reach either side, which is quite crazy. The reason we don't have it in one of these open habitats is because they're master escape artists, and we actually had that happen to one of our octopus many, many years ago. We had an octopus actually we noticed some of the fish were disappearing, and we weren't sure why. So we set up a video camera, and sure enough, the octopus was crawling out through the piping. Some people say piping, some people say grating. It was crawling out, going into the next habitat, eating a midnight snack, and then going back into its own habitat. So we tend to keep them in the bigger habitats with a nice, good lid so they don't do that.
All right, very sneaky. Mrs. Galato's class, do you guys have, I can see someone right front center of the camera, so we should probably check there.
You said that invertebrates come in all different colors and shapes. So is there a pink sea urchin? I'm excited.
A pink sea urchin. I don't know if it's specifically the closest we have. We've got a purple sea urchin and we've got a red sea urchin, and that is their common name. So for some reason, scientists aren't all that creative when it comes to naming sea urchins. I haven't discovered a pink one myself yet. We do have a number of pink sea stars, though. Actually, there's a rose star that's quite pretty. I recommend you look that one up.
All right. Well, Rachel, I wish we could steal questions from you all day long, but I know you do have another event to get to. So first of all, thank you to our classrooms. Thank you to our classrooms who are on camera, but also all the classrooms tuning in on YouTube today. Great questions from both groups. If you took some pictures, share them on Twitter. Tag at Van Aqua, tag Exploring by Seat of Your Pants, because we love to see pictures of classrooms in action. Tag at Ocean Wise as well. And Rachel, thank you for another great hangout. I think we have 4 more events this month, so we're excited for some more trips to the Vancouver Aquarium.
Yeah, these are some fantastic questions. I love doing these programs because you always make me think. Students, really well done. Keep asking those questions, keep being curious, because you're going to discover something amazing that you are passionate about, and then you can do something amazing with that too.
All right, I'm turning on the microphones, boys and girls. If you want to do a nice loud goodbye and thank you for Rachel, then we'll sign off for today. All right, perfect. I'm sure some of the inverts in the room heard that as well. Rachel, thank you so much. Good luck with the rest of your day, and we'll talk to you soon.
Yeah, talk soon. Bye, everybody.
Thanks, everyone.